Explanation of mechanism of brittle fracture. It is observed that when a tensile stress is applied to the specimen, then the applied stress is distributed about the crank in such a way the maximum stress occurs at its tips. The maximum stress at the tip of the crank is given by sigma f is equal to 2 sigma root of c by rho. When elastic material is stresses, potential energy is stored in the material before it cracks. This stored energy is known as elastic strain energy. When crack begins propagating, elastic energy is released. The crack propagates, new surfaces are created, and a certain amount of energy called surface energy must be provided to create them. Derivation for fracture strength. If it supposed that the crack propagates when the released strain energy is just sufficient to provide the surface energy necessary for the creation of the new surfaces. The elastic strain energy is released by the spreading of the crack of unit width is given by the strain energy per unit volume is equal to sigma square by 2E, where E is equal to Young's modulus of the material. UE is equal to sigma square by 2E into area into width is equal to sigma square by 2E into 5C square into 1 is equal to sigma square 5C square by 2E. Derivation for fracture strength. It shows that the strain-free volume is larger, the elastic energy released will be twice the value given in equation. U is equal to minus sigma square by C square by E. The negative sign indicated that the energy stored in the material is released as a crack forms. If gamma is equal to surface energy per unit area in joules per meter square, then the surface energy US for a crack of length 2C with unit width is given by US is equal to 4 gamma C. Total change in potential energy U is equal to UE plus US is equal to minus sigma square 5 C square by E plus 4 gamma C. This is the derivation for fracture strength. Mechanical test of material. The engineer and the designer need to know the hardness, strength, and other characteristics of the materials they use. The engineer and the designer should also know about the way in which the properties are determined. It can be noted that the test need to be conducted according to standard procedures so that one can have confidence in publishing the result. Classification of mechanical test. Destructive test. In these types of testing, the component or specimen to be tested is destroyed and cannot be reused. Example, tensile test, impact test, bend test, fatigue test, torsional test, break test. Non-destructive test. In these types of testing, the component or specimen to be tested is not destroyed and can be reused after the test. Example, radiography, ultrasonic inspection, etc.